everyone, I am Mary Swarnalatha, working as assistant professor in the Department of Electronics and Communication Engineering. In today's lecture, we are going to discuss about the problems on the stationary of a random process and the correlation of two random processes. First problem is find whether x of t is a Whiteside stationary or not if a random process is given as x of t equals to a into t, where a is a uniformly distributed random variable on the interval 0, 2. It means what they have given? They have given a random process x of t equals to a into t. So what is a random process? A random process is a function of both the sample space elements and the time variable. Or else simply can represent as what? X of t. So for a random variable, if you include a time function, it is called as what? Random process. Therefore, a random process is a function of both the sample space element. There is nothing but random variable and time. So in this random process, which is a random variable? A is a random variable and t is a time here. Now what type of random variable here? A is a uniform random variable, so which is distributed over the interval 0, 2. So for uniform random variable, what is the density function? Fp of A is equals to, so 1 by B minus A. So B here nothing but 2 minus 0 when x is from 0 to 2. So when x is from 0 to 2 and it is 0 otherwise. There is nothing but here 1 by 2. Therefore, what is the density function of the given uniform random variable for the interval 0, 2 is nothing but 1 by 2 when x is not x here. The random variable here, A is a random variable. So when A is from 0 to 2 and it is 0 otherwise. Now what you have to calculate? You have to find whether the given random process x of t is a Whiteside stationary random process or not. So for a Whiteside stationary random process, it has to satisfy two conditions. What is the first condition? The mean of the random process should be constant for all the values of t. What are the value of t? But its mean should be what? Constant. And second one is the autocorrelation function of that random process should be a function of only the time difference. So what is the time difference here? T plus tau minus t is nothing but what? Tau. So if these two conditions are satisfied, then you can say that the given random process is a Whiteside stationary random process. Now we will go for the first condition. We will find out the mean of the random process. So what is the first condition here? The mean of the random process, nothing but E of x of t is equals to E of, what is x of t? The given random process, nothing but A into t. So what is E here? Nothing but expectation. So the expectation always find out with respect to the random variable. Here E represents what? Expectation as statistical average. So the expectation will calculate with respect to what? Random variable. So in this A and t, which is random variable, A is a random variable. So t is a time. Therefore, we will find out the expectation of the random variable, which is random variable here. A is a random variable. So expectation of A. So that equals to t into. So what is expectation of A? Here A is a uniform random variable and which is what? A continuous random variable. So for continuous random variable, what is expectation of A? Nothing but integration minus infinity. Here in place of x, you have here A. So A into Fa of A dA. Because expectation of x for a continuous random variable, nothing but integration minus infinity x into fx of x dx. So if x is there here, I'll write down x. So x into fx of x dx. For discrete random variable, in place of integration, you take what? Summation. Therefore, t into, so integration minus infinity A into, what is the density function previously I written for the uniform random variable? A here nothing but 1 by 2 for what values of A when A is from 0 to 2. So when A is from 0 to 2, so we have to replace the limits minus infinity and infinity by 0 to 2 into dA. So that equals to t by 2 into, so what is the integration of A? Nothing but A square by 2. The limits are from 0 to 2. So that equals to what? T by 2 into 2 square minus 0 square by 2. Nothing but what here? 2 into t. Not 2 into t. So t by 2 into here 4 by 2. So that is nothing but t. So therefore the mean of the random process here it is not constant for all the values of t. So if any one of the condition is not satisfied, then I can say that the given random process is a not wide-sense stationary random process. So next question. Let two random process x of t and y of t be defined by x of t is equals to a cos omega t plus b sin omega t and y of t equals to b cos omega t minus a sin omega t, where a and b are the random variables and omega is a constant here. Show that x of t and y of t are jointly wide-sense stationary, and you have to assume that the random variables a and b are uncorrelated and they are of zero mean random variables, and the variance of the two random variables is nothing but same only. So they have given two random process x of t and y of t. What is a random process? A random process is a function of what? Both random variable and time. So in this, which is a random variable? A and b are the random variables. And here omega is what? Constant, and t is a time. And similarly in the random process y of t, here b and a are the random variables. Omega is constant here and t is a time. And what you have to show that? You have to show that the two random process x of t and y of t are jointly wide-sense stationary or not. So what is the condition for two random process should be jointly wide-sense stationary? The first condition is the means of the random process should be constant for all the values of t. And similarly, the mean of the second random process y of t should also be constant for all the values of t. Second condition is for two random process, for one random process you have taken the autocorrelation, for two random process you have taken the cross correlation. So what is correlation? Nothing but measuring the similarity between two random variables. So what is a correlation? Cross correlation with that random process x of t and y of t, nothing but rxy of t comma t plus tau. It should be what? A function of only the time difference. Nothing but what is the time difference here? T plus tau minus nothing but what? Tau only. So rxy of tau. So if these two conditions are satisfied, then you can say that the given two random process x of t and y of t are jointly wide-sense stationary random process. And moreover, they are given that the random variables a and b are uncorrelated. What is uncorrelated? Nothing but expectation of ab is equals to what? Expectation of a into expectation of b. And 0 mean nothing but what? u of a is equals to u of b is equals to 0. And they are given also that they are both have the same variance. Nothing but sigma a square equals to the variance of the random variable a, and the variance of the random variable is equals to sigma square. Nothing but same variance only. So these are the conditions they have given. So they have defined two random process, and they have given that a and b are the random variables, and they have given a and b are uncorrelated and the means are 0, and they have the both same variance. And you have to show that the two random processes are jointly wide-sense stationary or not. So we first will find out the mean of the random process x of t, and next the mean of the random process y of t. After that we will go for cross correlation between the two random process. If you get it is a function of only time difference, I can say that the two random processes are jointly wide-sense stationary random process. So what is the first condition we are saying? The means of the random process you have to find it out. So what is the mean of the random process x of t? Nothing but expectation of x of t. So what is x of t? They are given a cos omega t plus b sin omega t. And I told you that the expectation will find out with respect to what? The random variable. Here which are the random variables they are given? Only a, b are the random variables. So remaining terms you have to bring it outside. Therefore cos omega t, bring it outside into expectation of a plus here sin omega t into expectation of b. And what they are given that the means of the two random variables is nothing but 0. Therefore u of a is equals to 0 and u of b equals to, therefore the mean of the random process x of t is 0. So it is 0 for all the values of t. Therefore the one condition has been satisfied. And similarly, we are calculating the mean of the second random process y of t, nothing but expectation of y of t is equals to, so expectation of what is the random process y of t, they are given b cos omega t minus a sin omega t. That equals to, in this, which are the random variables, b and d are the random variables, so remaining terms bring it outside, then you can write this as what, cos omega t into expectation of b minus expectation of a into sin omega t. And they have given that the means of the two random processes 0. If you substitute, you will get the mean of the random process y of t equals 0. Therefore, the first condition has been satisfied. The means of the two random processes is constant for all the values of t. So, what are the value of t? The mean is constant. The first condition has been satisfied. And what they have given that the means of the two random processes is constant. So, what is the variance of the random process? A, nothing but expectation of a square minus u of a whole square. What is u of a is equals to 0 here. Therefore, sigma a square nothing but expectation of a square. And similarly, sigma b square, the variance of the random variable will be nothing but expectation of b square. And these two are considered equals to what? The variance sigma square. Now we are finding the second condition, the cross correlation function between the two random process x of t and y of t. So what is the cross correlation between the two random process x of t and y of nothing but rxy of t comma t plus tau is equals to expectation of x of t into y of t plus tau. What is x of t? They are given a cos omega t plus b sin omega t. And what is the second random process y of t? They are given b cos omega t minus a sin omega t. But in place of t, y of t, you have to replace by what? Y of t plus tau. So replace in this given random process y of t, replace t by t plus tau. Then we can write down y of t plus tau as b into cos of omega into t plus tau, nothing but omega t plus omega tau, minus a into sin of omega into t plus tau, nothing but omega t plus omega tau. Then just multiply and then simplify. Then you will get expectation of AB into, so just multiply here, A cos omega t into B cos of omega t plus omega tau. And here only AB are the random variables, so remaining terms cos omega t plus omega tau, bring it outside. Next, A cos omega t into minus A sin omega t, nothing but minus A square cos omega t into sin omega t plus tau. So only a square keep it inside, remainders bring it outside. Like that, you just multiply and then simplify. And after that, what they are giving that they are uncorrelated. Therefore, what is the expectation of AB? Nothing but expectation of A into expectation of B. What is the means of the two random variables? Nothing but 0. And they are given that the variance is nothing but same only. So expectation of A square nothing but what? Expectation of B square only. Therefore, what is Rxy of t comma t plus tau? So this term is 0. And here this C of AB is also 0. Therefore, we have the only two terms C of B square into sin omega t of cos omega t plus omega tau and minus U of A square into cos omega t into sin of omega t plus omega t square. And what is expectation of A square? Nothing but expectation of B square. So replace this expectation of B square by expectation of A square. Then you can get minus sigma minus expectation of A square into sin omega tau. Let us say that is equal to sigma square, then nothing but minus sigma square into sin omega tau. If you observe this, it is a function of only tau. It is not a function of both t and tau. It is a function of only tau. Therefore, the second condition is also satisfied. Since both the conditions are satisfied, I can say that the given two random processes are jointly White's and stationary random process. In the third question, determine whether x1 of t and x2 of t are jointly White's and stationary. And given that x of t is a White's and stationary random process, for each random process xi of t defined as x1 of t nothing but x of t plus a and x2 of t nothing but x of a t. So what they have given that? They have given that x of t is a stationary random process, a White's and stationary random process, nothing but WSS, nothing but White's and stationary random process. And they have defined two random process x1 of t. What is x1 of t? Nothing but x of t plus a. And what is the second random process? They have defined x2 of t is equals to x of a into t. And what you have to show that whether the two random process x1 of t and x2 of t are whites and stationary or not. Jointly whites and stationary or not, you have to find it out. So this is the question. So already we have seen the conditions for jointly whites and stationary. What is the first condition? The means of the two random process is constant. What is the first random process here? X1 of t. Therefore, expectation of x1 of t should be constant for all the values of t, and similarly, the mean of the second random process x2 of t should also be constant for all the values of t. And second condition, nothing but the cross correlation function should be a function of only the time difference, nothing but what? Rxy of tau. So these are the conditions for jointly whites and stationary. So we'll go for the first condition. What is the first condition? The means of the random process you have to calculate. So what is the means of the first random process? Expectation of x1 of t. So that equals to expectation. What is x1 of t? Nothing but they are given x of t plus a. And what they are given that x of t is a stationary, whites and stationary random process. It means what is nothing but it is satisfying two conditions. Nothing but the mean of the random process is constant for all the values of t. T may be anything but its mean is constant. And second one is the autocorrelation function is a function of only the time difference. So these two conditions are satisfied for this because they are given that the random process x of t is constant. Therefore, what is the expectation of x of t plus tau? Because for all the values of it is constant only. The expectation of x of t plus a is also a constant, nothing but x bar. So it is constant for all the values of t. And similarly, expectation of x2 of t. What is the expectation of x2 of t? Nothing but expectation of x of at. So what is the expectation of x of at? So whatever the value of t, it is a constant, nothing but x bar for all the values of t. Therefore, this is x bar only for all the values of t. Therefore, the first condition is satisfied. So we will go for the second condition, the cross correlation between the two random process. So Rxy of t comma t plus tau is equals to expectation of x not xy here, x1, x2 are the random process. So Rx1, x2 of t comma t plus tau is equals to expectation of x1 of t into x2 of t plus tau. That is equals to expectation of what is x1 of t, nothing but x of t plus a into what is x2 of t, nothing but x2 of t plus tau, nothing but x of a into in place of t or replace by what? T plus tau. So t plus tau that equals to expectation of x of t plus a into x of at plus a into tau. So whether we'll find out whether it is we'll find the time difference between these two. So what is the time difference between these two? Time difference is equals to at plus a tau minus t plus a. So minus of t plus a. So nothing but what you got here, a into, so if you take t as common, then you'll get t into a minus tau plus, if you take a as common, tau minus 1. It means what is nothing but here Rx1, x2 of, is nothing but what? Rxs of, what is the time difference here? T into a minus 1 plus a into tau minus 1. Nothing but it's a function of both t and tau. Therefore, the second condition is not satisfying. Therefore, the given two random process x1 of t and x2 of t are not jointly whites and stationary random process. Next question is define a random process x of t equals to a cos pi t where a is a Gaussian random variable with zero mean and variance sigma a square. Is x of t is stationary in any sense. So what they are given that x of t is a random process which has been defined by a into cos of pi t where a is a random variable. What type of random variable they have given? It is a Gaussian random variable with zero mean. Nothing but expectation of a is equals to 0 and the variance of the random variable nothing but sigma a square. And what you have to find out whether x of t is stationary random process or not. So for that what I am doing here, I am finding the expectation of the mean square value. Therefore nothing but expectation of x square of nothing but a square into cos square of pi t. So in this which is a constant here. So in this only a is a random variable, cos square pi t is constant. So you can bring this cos square pi t to the outside. Then you can write this as what? Cos square pi t into expectation of a square. So what is sigma a square? Nothing but what? Expectation of a square minus expectation of a whole square. What is the mean of the random process given as 0? Therefore, what is sigma a square? Nothing but expectation of a square. Therefore, cos square pi t into sigma a square. So, but if you observe this is depending upon the value of t. It should be constant actually, but it's depending upon what? T. So, what is the stationary random process? A random process is to be stationary if its nth order density function should not change with time, or if all its statistical properties should not change with time. But here, if you take this is a statistical property, nothing but the mean square of the random process, since it is a function of t, then you can say that it is not a stationary random process. The next one is x of t is a stationary random process with the mean of 3 and an autocorrelation function of 9 plus 2 into e power minus tau. So find the variance of the random process. So what they are given here, so x of t is a random process and the autocorrelation function of that random process is nothing but 9 plus 2 into e power minus tau. And moreover, they are given the mean of the random process x of t is equals to 3 they are given. So what you have to find out? You have to find out the variance of the random process is what? So what is the variance of the random process? Nothing but what? Expectation of x square of t minus expectation of x of t whole square. So what is expectation of x of nothing but they are given 3. So you have to find out what? You have to find out expectation of x square of t. So what is Rx of tau is nothing but what? Expectation of x of t into x of t plus tau. So if you keep tau equals 0, then what can you obtain? Rx of 0 nothing but what? Expectation of x square of t. So from this autocorrelation function, how do you find out the mean square of the random process? By keeping tau equals 0. So if you keep here tau equals 0, then what can you obtain here? Expectation of x square of t is equals to 9 plus 2 into e power 0 nothing but what? 11. And therefore, what is the variance of the random process? Nothing but expectation of x square of t. What is that value? 11 minus the mean of the random process nothing but 3 square. So therefore, the variance of the random process is equals to 2. Next question, given the random process x of t is equals to a sin omega t plus theta, where a and omega are constant. So each are the constant here. A and omega are constant. Theta is what? A random variable, which is what type of random variable it is? Uniform random variable, which is distributed over the interval minus pi comma pi. And they have given a new random process y of t. What is y of t? Nothing but they are given as y of t is equals to actually nothing but x square of t. So find whether x of t and y of t are jointly White's and stationary. So they are White's and stationary. You have to find out individually, and then you have to find out are x of t and y of t are jointly White's and stationary. So then what is y of t? Nothing but x square of t. What is x of t? A sin omega t plus theta. And what is y of t? You have to square it. Therefore that equals to what? A square sin square omega t plus theta. Next, what you have to first? What is the first problem? And what is here in this? Which is in this random process? A is constant and omega is constant. Which is a random variable? Theta is a random variable. Then what is the density function of that random variable theta? Nothing but 1 by pi minus of pi. Nothing but what? 1 by 2 pi when theta is from minus pi to pi and it is 0 otherwise. So, and what you have to find out whether x of t and y of t are White's and stationary. It means the first problem, what you have to do, you have to find out expectation of x of t equals to x bar. So, this is for a White's and stationary random process. And similarly, the autocorrelation function should be a function of only tau. So, find out the expectation of x of t. What is the expectation of x of t? Expectation of a into sin of omega t plus theta. So a is constant, bring it outside, then you can write down a into expectation of sin of omega t plus theta. Then the write the formula of sin of a plus b and then simplify, find out the expectation of x of t and then find out the autocorrelation function of the random process x of t. So if these two conditions are satisfied, they can say that it is a wide and stationary random process. And similarly, you have to find out for the second random process also whether it is a, what is the second random process here? Y of t nothing but a square sine square of omega t plus theta. And if we get a constant, the mean is constant, as well as the autocorrelation function of the random process y of t. If it is a function of only tau, then you can say that the first condition is satisfied. It means the first problem is solved, nothing but you have to show that x of t and y of t are wide and stationary or not. If these conditions are satisfied, then you can say that they are wide and stationary. And what is the second bit they have given? Are x of t and y of t are jointly wide and stationary or not? It means jointly means you have to find out the means. Already you have calculated the means of the random process. Nothing but u of x of t and u of y of t should be constant for all the values of t. And second one, the cross correlation. Here you have calculated individually. Here you have to find out for jointly wide and stationary. You have to find out the cross correlation. Nothing but rxy of t comma t plus tau. If it is a function of only tau, then you can say that the two random process x of t and y of t are jointly wide and stationary. So just find out the means and the autocorrelations and the cross correlation. Then you can say that if they are constant, then you can say that they are wide and stationary random process. Next question is, a random process is defined as x of t equals to a cos omega ct plus theta, where theta is a uniform random variable over the interval 0, 2 pi. So what they are given here, x of t is a random process which is defined by a cos of omega ct plus theta. So next one, what they are given here, which is a random variable. In this a is constant, omega c is also constant. So theta is a random variable. And what type of random variable it is? A uniform random variable. Then what is the density function of that uniform random variable? 1 by 2 pi minus 0, nothing but what? 1 by 2 pi when theta is from 0 to 2 pi. And it is 0 otherwise. Next, what you have to verify? Verify that process is ergodic in the mean sense and autocorrelation sense. So how do you find out that whether the process is ergodic in mean? So what is ergodicity theorem? If all the time averages are equal to the statistical averages, nothing but expectations, then you can say that it is a ergodic random process. So ergodic random process. What is the condition or for the ergodic random process? If all the time averages are equal to the statistical averages, then you can say that the given random process x of t is a ergodic random process. So how can you prove that the given random process is ergodic? In means you have to find out first the time average. This is how do you find out the time average? Nothing but limit t tends to infinity. Limit t tends to infinity. 1 by 2t integration minus t to t x of t into dt. This is nothing but time average. And what is statistical average? It's expectation of x of t. So if these two are equal, then you can say that the given random process is what? Ergodic process in mean. Similarly, you have to find out the time autocorrelation function and similarly the statistical autocorrelation function. So Rx is of tau and here x of t comma t plus tau. If both are equal, then you can say that the given random process is ergodic in the autocorrelation. And next problem is, show that x of t is a wide and stationary but not strictly stationary. So what is the difference between wide and stationary and strict and stationary? So wide and stationary nothing but it has to satisfy only two conditions. The mean should be constant and the autocorrelation function should be a function of only the time difference. But what is strict and stationary? Strict and stationary means all the statistical average should be constant. They should not depend upon t. Then you can say that it is a strict and stationary random process. So you have to show that x of t is wide and stationary but is not strict and stationary. And what is x of t? They are given a cos omega naught t plus b sin omega naught t. And here which is the random variables? A and b are the random variables. And then omega naught is a constant. So, and the random variables have the zero mean and they have the different density functions but have the same variance. The variance of the random process is constant and they have the zero means. So, we have to show that x of t is the Whitesian stationary. So, the condition for Whitesian stationary, the mean should be constant and the autocorrelation function should be a function of only the time difference. How can you say that it is not strict stationary? You can find out the statistical average of anything. You can find out the mean square, value, skew, whatever it may be. If you get it is a function of t, then you can say that it is not strict stationary, but it is satisfying. Only two conditions can say that it is a Whitesian stationary random process. So find out the autocorrelation function and find out if we are getting the value is equals to what here? Sigma square into cos omega naught into tau. So it is a function of only tau. There you can say that given random process is a Whitesian stationary random process. The next one is find expectation of z, u of z square and sigma z square random process z of t equals to x1 cos omega naught t minus x2 sin omega naught t. And here omega naught is a constant and x1, x2 are the random variables. So what type of random variables they are? Gaussian random variables and they are independent random variables. Independent nothing but what? Expectation of x1 into x2 is equals to what? U of x1 into U of x2 with each zero mean. Therefore, U of x1 is equals to 0 and U of x2 is equals to 0 and the variance of the two random variables is a constant that equals to what? Sigma square. So what you have to calculate? You have to calculate expectation of the mean of the random process. The second one you have to calculate the mean square of the random process. And third one you have to calculate the variance of the random process. Nothing but what? Expectation of z square of t minus expectation of z of t whole square. So you have to find out the mean of the random process, mean square, and then you have to calculate the variance of the random process. Next question is find the mean, variance and average power for a stationary aeronautical process having the autocorrelation function with the periodic components as. So what they are given that they have given the autocorrelation function of the random process x of t nothing but 25 plus 4 by 1 plus 6 tau square into cos 2 tau. What you have to calculate? You have to calculate the mean. So how do you calculate the mean? Nothing but what? You have to calculate. So here this consists of both DC components and AC components. So you have to take only the DC components. The autocorrelation function consists of what? Both the DC components as well as the AC components. So in order to find out the mean, you have to consider only the AC components. Then what is the mean of that random process? Nothing but what? Limit mod tau tends to infinity Rxs of tau of the DC components. Nothing but limit mod tau tends to infinity 25. Nothing but what? Is equals to x bar square is equals to 25. That implies what is the mean of the random process? Plus or minus 5. Next, what is the variance? Is nothing but. So before finding the variance, first you'll find out the average power. What is average power? Nothing but expectation of x square of t is equals to what? Rxs of 0 only. What is Rx of 0? So 25 plus 4 by 1 plus 0 into cos 0. That is nothing but 29. Therefore, what is the average power? Nothing but 29 watts. And what is the third one you have to calculate? You have to calculate the variance of the random process. So you have to calculate the variance of the random process. Nothing but what? U of x square of t minus x bar whole square. What is u of x square of t got? 29 minus plus or minus 5 whole square. That equals to what? 4. The variance of the random process nothing but what? 4. So today I have calculated the problems on the stationary random process, Whitesian stationary random process, and have calculated the autocorrelation cross correlation of the random process. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.